At this point, we've covered what's in concrete, how it's made, how it gets hard, and how we can use chemicals to change and improve its properties. Now let's take that information and use it to begin to understand how and why we use this incredible material so much during construction. To start that conversation, you need to understand exactly what I really mean when I say concrete is strong and that it's a durable building material. So let's talk about concrete strengths and about concrete weaknesses. You'll often hear concrete referred to in terms of its strength. You may hear things like this is 3,000 psi concrete, or 5,000, or 7,000 psi concrete. When people throw around these numbers, they're actually referring to its 28-day compressive strength, or if you want to be a little more precise, this is the expected compressive strength of the hardened concrete in pounds per square inch when it's 28 days old. Compressive strength is where concrete really has its advantages. Even concrete on the low end of the strength spectrum, like 2,500 or 3,000 psi concrete, that's incredible compressive strength. Those numbers refer to the fact that it's going to take a force equivalent to 3,000 pounds per square inch to crush that concrete. An example I always use to put that into perspective is that if I were to cut out a 6-inch diameter core of concrete from a concrete floor in a house, that would be strong enough to support that whole house without being crushed. The key here is understanding compressive strength and what that really means to the concrete structure itself. Compressive forces are forces that would tend to crush something or squeeze it together. And again, this is where concrete excels. One of the limitations of concrete, though, is its tensile strength. Tensile forces are the forces that would pull something apart, and concrete has a relatively low tensile strength when you compare it to its compressive strength. To give you an idea, most estimates will state that the tensile strength of concrete is only about 10% or even less of its compressive strength. Get a little more precise, some design manuals will refer to a calculation of 6.7 times the square root of the compressive strength. Now, a lot of this depends on some specifics in the mix design, like water-cement ratio and aggregate size. But still, this means that our 3,000 psi concrete only has a tensile strength of probably at most 366 psi. And even our high-strength 7,000 psi concrete probably only has a tensile strength of about 560 psi. Another way to look at this is by picturing a concrete slab sitting on the ground. If I walked up to that slab and I started hitting it in the middle with a sledgehammer, I'm going to have a hard time crushing it. But if I take that same slab and I suspend it or I prop it up on one side, I can now probably hit it in the middle and get it to bend and break. So when we're talking about concrete being used to build a wall or a long beam or a bridge or a tall column, this tensile strength is really important because it refers to that bending strength. When wind blows against a concrete wall, it's going to try to bend that wall, putting the face of the wall being hit by the wind into tension. When gravity pulls down on a concrete beam that's supported on columns on either end, the bottom of that beam where the bending forces occur is being put into tension. So at that point, I don't really care that my compressive strength is 7,000 psi. I care that the tensile strength is probably only 560 psi. Now, again, I can alter my mix designs to increase tensile strength, but even though this is a really important number, we still rarely refer to concrete using that tensile strength designation. We just use its compressive strength. So the reason I'm explaining this is so that you understand that sometimes the reason a designer wants to use higher strength concrete or go from 3,000 psi concrete in a beam up to 7,000 psi concrete may really have very little to do with actually needing more compressive strength. They're really just trying to get more tensile strength. We can generally say that concrete is strong in compression, but it's weak in tension. Let's take a look at what we can do about that.